Welcome back to my office hours. In this video, we will discuss two example problems. The first one is about primary dimensions and the derivation of a dimensional formula. The second one is about density in various units. Problem 1. Surface tension gamma is the tendency of liquid surfaces at rest to shrink into the minimum surface area possible. It can be calculated using the following equation, where F is the force that draws molecules on a liquid surface to its interior, and L is the length of the movable side of the fluid. What is the dimensional formula of surface tension consisting of primary dimensions only? Solution. To work on this problem, let's clarify what a dimension is, and what primary dimensions are. A dimension is any entity that can be measured using units. For example, is mass a dimension? We know that mass is an entity, and it can be measured using units such as gram, kilogram, pound mass, and so on. Therefore, mass is a dimension. Primary dimensions, sometimes called basic dimensions, are defined as independent and fundamental dimensions, from which other dimensions can be obtained. The primary dimensions are mass, length, time, temperature, electric current, amount of light, and amount of matter. In fluid mechanics, there are three frequently used primary dimensions. They are mass, m, length, L, and time, t. The dimensional formula is the use of only primary dimensions for any given dimension. Taking the dimensional formula of force for example. Force is defined as mass times acceleration. Acceleration is defined as the velocity over time. Velocity is defined as distance or length over time. Therefore, going backwards, acceleration has a dimensional formula of length over the square of time. And then, force has a dimensional formula of mass times length over the square of time. Okay, now let's talk about this problem about the dimensional formula of surface tension. According to the equation given, surface tension can be determined after measuring force F and length L. Based on our previous derivation of the dimensional formula of force, we know that force F has primary dimensions of mass times length over the square of time. Dividing force F by length L derives mass over the square of time. Therefore, the dimensional formula of surface tension is mass over the square of time. We need to know that the 1/2 in the surface tension equation will not affect its dimensional formula, because numbers are dimensionless. Problem 2. If 200 cubic feet of oil weighs 10,520 pound mass lbm, calculate its specific weight in the unit of pound force per cubic foot, density in slugs per cubic foot, and specific gravity. Note that in the traditional unit system, gravitational acceleration is 32.2 feet per square second, and gravitational constant is 32.2 pound mass feet per pound force square second. Solution. First, let's talk about the specific weight in the unit of pound force per cubic foot. The definition of specific weight is weight over volume. Weight is mass times gravitational acceleration. That is, weight 10,520 pounds mass times gravitational acceleration 32.2 feet per square second. However, we must be aware of the unit here. Unless we apply the gravitational constant 32.2 mass feet per pound force square second, the specific weight won't be in pounds force per cubic foot automatically. Now, let's talk about the density in slugs per cubic foot. One slug is a mass equal to 32.2 pounds mass based on standard gravity, the international foot, and the avoirdupois pound. In other words, at the Earth's surface in standard gravity, an object with a mass of one slug weighs approximately 32.2 pounds force. Hence, using the gravitational constant 32.2 mass feet per pound force square second, the density in slug per cubic foot is calculated following the definition of density of mass over volume. So now we can find the answer as shown. For specific gravity, the standard or reference material for liquids and solids is always water at 4 degrees Celsius. In this problem, we have calculated the specific weight of the oil as 52.6 pound force per cubic foot, and we know that the specific weight of water at 4 degrees Celsius is 62.4 pound force per cubic foot. Therefore, the specific gravity Sg equals to their ratio, that is, 0.84. Thank you for watching. Leave a comment if you like to see more videos with example problems.